Welcome to my YouTube channel. Today I am going to discuss about the topic hybridization, which is very important topic for NEET examination as well as others competitive examination. I have selected 4 questions on this topic and which I have written on the board. So let's check it out. My first question is, which of the following species has tetrahedral geometry? I have 4 options. So to make a tetrahedral geometry, central atom required 4 atoms which are surrounded that central atom. That means here only the option where boron, that is central atom, is surrounding by these 4 hydrogen atom. In other cases, here the central atom is nitrogen, which is surrounding by 2 hydrogen atom. Here the central atom is carbon, which is surrounding by 3 oxygen atom, and here the central atom is oxygen, which is surrounding by 3 hydrogen atom. So that means in option A only there are 4 surrounding atoms. That means A is the right answer. So BH4 minus has tetrahedral geometry. So my next question, that is question number 2. Which of the following has maximum number of lone pair associated with xenon? So xenon has a fixed number of valence electron. Out of these valence electrons, some electrons is used to form a bond or a numbers of bond, and others electrons make lone pairs. So we can see in XeO3, as oxygen is bivalent, so the 6 valence electron of xenon is participating to form covalent bond with 3 oxygen atom, and rest of the valence electrons makes lone pair. But in option number B, as fluorine is monovalent, that means 4 valence electron of xenon is participating to form covalent bond with fluorine. Others remaining electrons, valence electrons, is used for lone pairs, or they form the lone pairs. In question number option C, 6 valence electron of xenon is participated to form bonds. But in option number D, only 2 electrons is participating to form the bonds. So minimum number of valence electrons is used to form bonds is in this compound. That means maximum remaining electrons is present to form lone pairs in this compound only. So the answer is D. My third question, the correct order of bond angles in NH3, PCl3 and BCl3. So bond angle. Here in nitrogen and phosphorus, they both present in same group in periodic table, and they have 5 valence electron in its outermost shell, and they form 3 bonds with other elements. That means they have 5 plus 3, that is 8 number of valence electrons in its valence shell, which produce 4 pairs. That means nitrogen or phosphorus both are in sp3 hybridization, which creates a bond angle of 109.5 or nearly 109.5 in these 2 compounds. But in BCl3, boron has 3 valence electron and it forms 3 bonds with chlorine. That means 6 electron, so 3 pairs of electron. So the hybridization of boron is sp2. That means in this compound the bond angle is 120 degree, which is much greater than these 2. So in option 4, out of this option 4 options, only in this option BCl3 is in the highest position. In others option BCl3 is not in the highest position, but we can see that BCl3 should have higher bond angle. So the option D is our right answer. And question number 4, that is the last question but not the least question. Anyway, the structure of IF7 is, what is the structure of IF7? I is a halogen, so it has 7 valence electron. So if it bonds with 7 fluorine, which are fluorines are monovalent, so it takes more 7 electrons from 7 fluorine. So how many electrons in I in its valence shell? That is 14 electrons. So how many pairs? It's 7 pairs. So 7 pair means it must have the geometry like pentagonal bipyramid. So the structure is pentagonal bipyramid. That means 7 pair always create pentagonal bipyramid. So we can say in this regard, that is, if the pair is 2, then it is sp. If the pair is 3, then it is sp2. If the pair is 4, then it's sp3. If the pair is 5, then sp3d. If the pair is 6, then d2sp3 or sp3d2. If the pair is 7, then the hybridization is d3sp3. That means pentagonal bipyramid. So that's all which I want to say. Anyway, thank you for watching my video. Thanks a lot.